Hello, and welcome to the Center for Energy Education online learning series on climate change. Hi, I'm Dr. Petra Zimmermann, Chairperson and Associate Professor of Geography at Ball State University in Muncie, Indiana. I'm also a climatologist. So I'm going to tell you a little bit about why we can't take a cold snap or a warm spell and say, oh, that's evidence for or against climate change. So let's suppose you experience a major cold snap in places where winters are generally mild. In fact, we saw that in February 2021. We had the cold snap that brought a lot of snow and ice to the southern part of the United States. Is that evidence for that climate change is not occurring? Does that mean that climate change is bunk just because it got so cold? The answer is no. I'm going to flip the scenario, okay? I live in Indiana. It gets cold here in the winter. Cold enough that several times a year, several times in the winter, I'm dripping my faucets to make sure that my water pipes don't freeze because it's kind of expensive to repair that. So it gets cold here. But a couple of Januaries ago, I was outside bicycling in a t-shirt and shorts. And you have to understand, when it comes to cold weather, I wimp out. I'm getting all bundled up and I look like Michelin Man. I have so many layers. So if it's January in Indiana and I'm outside in a t-shirt and shorts, it must be pretty darn warm. So someone might say, that's proof that the climate is changing and it's becoming warmer. Again, I'm going to say, no, that warm spell is not proof of climate change. Why? I'll tell you why. Because now we've had two separate scenarios. One which would ostensibly say no climate change. The other one would say, oh, definitely climate change. Those two examples I gave you are examples of weather. And weather, even though it occurs in the atmosphere, is different than climate. So let's take a look at what weather is. Weather is the short-term state of the atmosphere. In other words, weather is when the meteorologist tells you it's going to be warm for the next 5 days. Climate, on the other hand, is a long-term state of the atmosphere. Climatologists might tell you, oh, it's going to be warm for the next 10,000 years. So there's a real time difference here. So a single weather event, even a single year, is simply not enough to see climate change evidence. You need to look at a longer time scale. Okay, so this February 2021 cold snap brought snow and ice and power outages to places like Texas. And while that was happening, other places were experiencing unusual warmth at the same time. So while the American South was buried under ice and snow, places like Greenland are actually experiencing unusual warm temperatures at the exact same time. So one is not evidence for or even evidence against. Let's step back a minute and think of another cold spell. In February 2015, we had in the United States, the eastern half of the country was experiencing bitterly cold temperatures for several weeks even. It was the polar vortex, and it gave the eastern U.S. very frigid air. At the exact same time, in Alaska, home of the famed Iditarod sled dog race, the starting point had to be moved. Why? Because there wasn't enough snow. They had to move the start to a place where there's actual snow. It was simply too warm in Alaska. And this was going on at the exact same time it was so bitterly cold in places like Indiana or Ohio or other parts of the eastern U.S. So the western U.S. saw extreme warmth. The eastern U.S. saw bitter cold. Okay, so that in and of itself is not evidence for climate change either. So what does evidence for climate change constitute? Well, we're looking at the long term, which means we're looking at decades or centuries or even millennia, depending on what kind of climate change we're examining. We're not looking at days or months or even a couple of years. So with climate change, we want to look at average conditions. there's always going to be some variability in the atmosphere. Some days it'll be a little warmer than normal, and some days it'll be a little colder than normal. In fact, the National Weather Service, NOAA, the National Oceanic and Atmospheric Administration, define climate normals as averages for 30-year periods. So there's always going to be some variability. Some days it's warmer, some days it's a little colder, but you want to look at the longer term. So if you want to look for evidence in climate change, you want to see, are these cold snaps or warm spells, are they increasing in frequency? If you have decades worth of data, are we getting warmer or are we getting colder? That's evidence for climate change. Are these cold snaps and warm spells becoming more frequent or less frequent? That could signal a change in the jet stream. And the jet stream is what drives many weather patterns. In other words, it helps us steer storms certain places. The jet stream, incidentally, is a fast-flowing zone of air way above the surface. But it helps move storms from the west to the east. So if you have a jet stream that generally moves west to east, cold air stays poleward, warm air stays towards the equator. But when it moves up and down, you get more of a north-south trajectory. Well, cold air from Canada and Arctic regions can funnel down into the United States. And along with that, where you have the cold air funneling, where you have this dip, where there's a ridge, you've got warmer air that rises up to places where it's usually colder. So if you're seeing changes in the jet stream, the position of the jet stream changing over time, that also is evidence of climate change. But with respect to climate, what we're doing is looking for averages. So there's always going to be some kind of up and down nature with temperatures or even precipitation. And when there's a disturbance, there's going to be a response to the disturbance. Eventually you reach a new normal, which is called steady state. Okay, so let's consider a disturbance in something that flows. Water and air both flow. I'm going to give you an analogy. Suppose I have a big tub of water, nice level water at the top, nice and smooth, but I throw a rock in. Throwing a rock in is a disturbance, and what happens is I get ripples of water, some of which are above the water level previous, and some of which are below that previous water level. Eventually the ripples become smooth again, they die out, and we get a steady state. Well, the same thing is happening in the atmosphere. In this case, the disturbance is adding greenhouse gases to the atmosphere, so you will see some up and down motion of temperatures. But eventually there will be a new normal, and that new normal will be warmer than the current normal. So what does climate change evidence mean? We're looking at the long term. We're looking at responses to disturbances in the atmosphere, and we're making sure that what we are examining is not individual points of data, but a collection of data. So I want to thank you for watching. And to learn more about climate change, please visit center4ee.org. That's center4ee.org. Thank you.